Good morning, everyone. Chris Wong here, partner at ZS. And so just a little clarification, I was on vacation in Hawaii last week, and so I'm actually based in San Francisco. So very happy to be here to talk to you guys about, a lot of big words here today. But maybe just very quickly about ZS first in terms of what we do. For those of you who don't know, we're a professional services firm, 40 years in business, about 13,000 employees, and about 85% of our business is in the healthcare space. And so we're pretty complete when it comes to the understanding of the healthcare ecosystem, as well as all the data, all the nuances, and everything like that. So yes. So starting here first, we all know the healthcare supply chain is fairly complicated. And you got all of these different owners, players, and all of those things in the ecosystem. And one of the things that ZS we actually specialize in is in data. So a little bit of story of how ZS was founded was actually 40 some years ago. Two professors from Kellogg at Northwestern found a way to use data to align sales reps a lot better. So if you did some analysis and say you need about 40 sales reps in the U.S. to cover the entire country, how exactly are you going to split those 40 sales reps up into their individual territories? Well, they found a way to use data to do that, and so it just kind of expanded from there. But one of the things that's been still constant through the journey of our company is everything that we do, we like to use data to make those types of decisions. And I'd like to think of ourselves as data scientists before it was cool. Right? And so when we see these problems where there are a lot of different players in the ecosystem, I'll stand over here, we get excited about these things because we see the opportunity to connect all of the data sources together and do something meaningful out of it, whether it's solving inventory challenges or forecasting better so that you don't have to waste so much supply in your clinical supply. Those are kind of like the types of problems that we solve and all those types of things. Okay. So what we want to talk to you guys today is we want to share 3 use cases where we were actually able to combine data from various different places to actually drive some sort of change, right? The first one has to do with how are we able to increase customer satisfaction when it comes to returns and refunds. The second one has to do with providing that visibility into shipments for products with a really, really short shelf life. And then the third one is taking a look at a company, whether they want to optimize their supply chain a little bit more in terms of their shipment costs. So deciding what's the mode of transportation that actually should be used when it comes to shipping things across the Atlantic. Right? But in all of these things, you'll see a constant thing is that there's a lot of data sources coming together. We find some way to merge it together and then make something out of it, right? And so this flows very well with the Min platform where a lot of the data can actually come together. All right, so the first one, it cannot be at a TraceLink conference and not talk about serialization data. And so this one definitely has serialization data. So you'll see a little bit in terms of the data sources that we're actually using in each of these use cases on your upper right-hand side. But basically, we all, returns happen, and from buying things from your department stores. But one thing that actually does happen is that for certain drugs, you actually can return it. There are these things called sellable returns and non-sellable returns. But these things do actually indeed happen in the pharma industry, and sometimes the return happen when it's done by the wholesaler, and sometimes it's actually done by the end users. And so in these use cases, let's focus on the ones that are returned by the end user. So this can be, your hospital nurses, or it can also be individual patients as well, depending on, where these therapies are actually being administered, right? So if it's something that is like a, auto-injector pen for your insulin or, your GLP-1, the person doing the return would be, individual patients. But if it's like, an infusion product, it will more likely or not be, someone, it might be some nurse at the infusion center or at a particular hospital, right? And the problem that we're trying to solve is pretty interesting. So in the US, there are many different ways to purchase drugs. And depending on your entity, you may be eligible for discounts, right? The most famous one is 340B. And if you're a 340B entity, you can purchase, certain set of drugs at a discount, right? But what we also know in this market, and hopefully you guys have all heard of this 340B diversion problem, where a 340B entity buys a particular product at a discount. Somehow that product ends up somewhere else that's not a 340B entity, and that product either get used or something happens to it. And it's a big problem for pharma manufacturers because they should be paying the full price for that particular product, but somehow they were able to get access to this cheaper 340B product that may look a little bit different because the packaging may be a little bit different, but the content of the product is exactly the same. Right? And so, patient efficacy, everything is the same. It's just that the price is a little bit different. And so when these types of 340B diversions happen, the pharma company is, basically cheated out of some money. Right? And one of the routes where people can actually do this is through returns. So the way they would actually do this is they would buy the product at a 340B price, right? And then they would return the product. Now, because of how the pharma supply chain works, you buy it through a wholesaler, and when you do the return, you usually deal with the manufacturer themselves. The manufacturer doesn't usually know how much the company actually paid for the product. Right? And that becomes a difference, right? And so if I take a product and go back to my manufacturer and I say I want to return it, they don't know how much I pay for it. And so a lot of the times, manufacturers will say, you know what, I'm just going to refund you the wholesale acquisition cost, which is the list price of the product, right? And so now, all of a sudden, you can actually make a little bit of money on the side if you're doing these types of things. Right? So what we've done is we've actually seen this done before with two of our fairly large, well, probably the largest biopharma manufacturers on the West Coast, right? So what they do is they actually use the serialization data here. Because what they do is they need to marry up two data sets. First is when they sell the product to the wholesaler, right? Obviously, they sell it at the full list price, and let's just call that $100 just to make the math a little bit simpler, right? And when the wholesaler sells it to the hospital, if it's being sold at a discount, they need to let the manufacturer know, right? And that's usually done through the chargeback data. Some of you may know that's called the 844 data set, right? But that data set basically says, hey, manufacturer, I sold these at discounts, and you need to pay me back that money. So 844 data, it's definitely shared between the wholesaler and the manufacturer because the wholesaler wants to get paid back for that, right? But what the manufacturer is then requesting is for those units that are actually sold at a discount, give me the serial number of those things as well. Right? So now I know these vials or bags or what have you are sold at discount, and I know exactly the serial number that goes along with it. Right? And so now the beautiful thing about this particular use case is that it doesn't really matter what happens in the middle, right? Because all that matters here for this particular use case, right, is when a return actually does happen, right? And it may be a 3PL who's providing the return service on behalf of the manufacturer. What they need to do is, I just need to know the serial number of that particular product that you're returning, right? Because now I can link up that serial number to the list of serial numbers that were discounted at the very beginning, and then I can match it up, and I can see whether it was actually bought at a discount or not, right? And so it's a pretty elegant use case, and it's a great use case for actually using the serialization data, because I think one of the key challenges that we all know about is it's hard to get the intermediate node to actually send you the serialization data. But this one, you just really need to know at the beginning and the end, and then you need to link all the data together to be able to do this better. Okay. All right, with that, I'll pass it over to my colleague Bharathi to walk through the other two use cases.
Thank you, Chris. Thank you, Chris. My name is Bharathi Shankar. I'm part of ZS Associates as well, and I'm based out of Los Angeles. So the second use case that we'll talk about is focused on getting the delivery to your end customer, the right time with a challenging set of circumstances, which is the product has got really short shelf life. We're talking a matter of few days, right? 2 to 3 days, right? And with that, right, ticking clock, right, how do you ensure that the right product gets to the right customer at the right time, right? And that's a challenge that a lot of people are now starting to focus, especially with some of these advanced therapies. I know Dan yesterday, for those of you who were on the session yesterday, was talking about how a lot of the diseases, they're changing, and we are now moving a lot more towards, right, cell therapy and gene therapy, right, some of those advanced therapies. And with that, right, they all have, right, the vein to vein challenges, which make it unlike traditional supply chain challenges. So with that, the data that you would need to historically track is you would get something from a 3PL and it's a status message, and then you're like, all right, I'm done, right? But that's changing. The way that you serve your customer is by telling them, giving them visibility into where their shipment is, and giving them heads up if things are not getting to them at the right place. You do that normally, it becomes even more challenging with a short shelf life, right? And that means you would need to combine again to your, in the top right hand side of it, right? Is there are information that you would need to combine both from your internal sources. Your internal systems often don't talk to each other themselves, right? So now you need to combine your internal sources sitting in multiple silos. And then you need to combine that with external data. External data is also twofold. One is information from your carriers or LSPs, right? Logistics service providers. And thirdly, you also need to combine that with external information such as weather data, right? Traffic information. Look, I need to take this to Burbank Airport, but maybe I shouldn't go to Burbank. Maybe I should go to LAX, right? So those type of like granular information that you would need to take into account. So that's the complexity of it, right? So these challenges, and any time you miss anything, right, the patient it's going to be directly impacted. So if you consolidate all the different challenges that you would see in the logistics ecosystem, you're running into 2 or 3 issues, right? One, where is it? It's a visibility issue. Two, I can't. The information is sitting in multiple places. I need to combine it for it to make sense. Connectivity becomes the second issue, right? Which is where TraceLink comes in and plays a major role, right? Mint platforms such as Mint. Thirdly, once you have all the information, do you understand the trade-offs that you'd need to make? What if I do A? What's the cost? What's the service impact? What if I do B? What's the cost? What's the service impact? So you need to be able to make decisions as events are happening and unfolding, right, in a very quick manner. And the way that we did it, right, so we work with a lot of radio pharma companies, and we work with a lot on advanced therapies, cell therapy, and gene therapies as well. So this particular use case is focused on a radio pharma client, and the way that we worked together with them is we brought in all the data sets into one place. That included their internal information, external information such as logistics service providers, and then thirdly, GPS information, and fourthly, real-time information from flight sources, traffic, etc. We helped plan the shipment based on historic information. Look, you shouldn't even give this to this carrier because they've got a poor service level on this lane, right? So we went down to that level of granularity. We leveraged historical information and current information, and we gave them the route that they should take. This first part. Second part is once the shipment's been picked up and it's out your door, right? So we helped our clients with identifying issues. Look, this particular shipment is at risk. The ETA and everything is calibrated towards the time that the medicine is going to be injected into the patient, right? And look, that time is at risk because the shipment may not get delivered. That would, again, directly impacting customer experience because the patient's probably already there and they have booked a hotel room and they're probably going to be scheduled for surgery or scheduled for injections that day. So we identify the issues and we alert the customers real time, and you're not waiting for just LSP to tell you or 3PLs to tell you that something is wrong, right? So you're owning that and you're saying this ETA is now changed. Now this is the new ETA. So we identify that. And lastly, reporting, right? So you don't want to sit in front of a 3PL provider during your QBR and they bring their own reports saying everything is hunky-dory, right? So you want accurate information, single source of truth. So we helped put the solution together for one of our clients. So this is one use case. So the next one I want to spend some time on is things that we often always face. Look, we all expedite. Right, it's just part of being in logistics. The question is, when do you expedite and when you don't, right? And a lot of times it's based on who yells the loudest, right? Oh, this customer is important, I need it, right? How are you able to make data-driven decisions? So that's one of the use cases that we helped one of our clients on. It's a UK based client. And the way that we had to do that was internally their data was sitting in, as we can imagine, silos, right? Meaning an expedite decision is not just based on transportation costs. It's based on inventory cost. It's based on inventory carrying cost. It's based on what's the cost of loss of revenue, right? Multiple of those factors play in. And you often expedite when you don't have enough inventory, right? And having inventory is something that, again, because the systems don't talk to each other, do you need to expedite from point A to B, or can you transfer something intra-facility or inter-facility within the same state, within the same region? So those were all the nuances that we had to account for. And again, the top right-hand side, right? So what are the rates? They didn't have often the transportation rates that they would need to expedite, right? Inventory information, flight status, ocean schedules. So the focus for us was, should it go via air? Should it go via ocean? In its simplicity, that was the use case, right? But then it wasn't that, right? So of course, ship it by ocean, right? It's cheaper, right? It was not that, and we had to account for inventory information, account for flight information, ocean information, and doing a lot of that. How can we optimize transportation mode decisions that ensure that you are able to deliver the product reliably, right, at the right time, the right place? Some background about this. So this again very much an AI use case, right? So where we are, we built a tool to automate that decision, right? Historically, it's been that you always ship something via air. So we changed that, and we again took in information from multiple places, and we said, look, we'll automate this, but then the default is always going to be ocean. Now we are flipping it, but then we are telling you when to expedite, right? And anytime we identify a risk, again, like ML algorithms determine, right, when you are going to have an issue. So as soon as we identify it, we flag it, and we had the governance model built in as well, and then that shows this is when it should go air, right? And that accounted for information from all of those. Reasonable, right? We're talking about millions of dollars in savings, the way that we did that. And the tool does something against a lot of this information that need to come together, right? Now they were looking at options that they could compare, right? What if I send it by sea? What are the trade-off decisions? What is the cost of action? What is the cost of inaction? If I don't do something, when will it get there by, right? There is always, like, I mean, we all know sailing schedules. We all have transit times. What is the transit time? What is the transit time variability? What is the inventory? What is the inventory variability? Supply variability. So we accounted for a lot of that, right? And we standardized the decision-making process. We switched, obviously, air to ocean. Sustainability was a big part of it, right? Again, when you switch something from air to ocean, CO2 emission savings is like 95%. It significantly helps, right? And then lastly, automating and recording workflows. The decisions that were being made to serve the customers, look, the customer needs it today, I need to expedite it, again, was based on whoever yells the loudest, right? We automated that, and we recorded when was the decision made and why was that decision made. Was that an inventory problem, or was that an airline reliability problem, or transit reliability problem, or ocean carrier reliability problem? So we were able to identify that and automate and record the reason codes behind that as well. So all of that, right, was focused on all the three use cases that we're talking about directly serves customer experience, because oftentimes logistics is the face of a company to a customer. You receive a product from someone, right, and the person who signs for it, right, that's the impression that you leave on people, and therefore getting logistics right is a big part of improving customer experience. Getting logistics right happens only when the data sets talk to each other, right? And when they come together and you're able to make a holistic end-to-end view of your supply chain. So with that, let me open it up for any questions.
Yeah, thank you for the presentation, guys. Chris, I thought the scenario that you showed is very interesting with regards to return. So it is my understanding that when a product is returned from the end user, call it a clinic or a hospital, to a wholesaler, the wholesaler needs to verify the serial numbers that are returned. My question is, do you see that verification happening? And is it happening through VRS?
Yeah.
Or is it happening with EPCIS data? Or how are those returns verified at the wholesaler?
It's oftentimes an interesting question. The return space in the pharma world is shady. I'll just say that because one of the biggest challenge is if the product comes in a box, I've thrown away the box already, right? The secondary packaging and the serial numbers on the secondary packaging, and so you see a lot of challenges with that. But assuming when they are actually returning those things in full, then it really just depends on the capabilities of the wholesalers. The big three obviously has the capabilities to do so, but more and more in the U.S. we're seeing these smaller, I don't want to call them smallers, but more niche type wholesalers pop up, and those niche type wholesalers tend to have a little bit more varying ways in terms of how they. But the more established ones definitely they have their ways and the methodologies to do the verification pretty seamlessly. Again, if that primary package if that secondary packaging is available.
Yeah, extending the same question, right? So usually when the VRS verification happens when it is a saleable return,
Yep.
right? But when it comes back to the wholesaler and wholesaler is able to sell it back to someone, then they do the VRS
Yep.
verification first and they sell it back. But in your presentation, you said that when they are referring to a credit, that means they are not going to sell it, right?
It depends.
It's a return,
yeah.
right?
Yeah. It depends on the type of return that is requesting. So what we usually deal with, and again, sellable return, non-sellable return, it's usually the non-sellable return.
Yeah.
That seems to be where more of these bad
But-
actors.
But none of our
Yeah.
customers give us a serial data when they return a bottle to. They never send a lot level data. They, I mean, lot level data probably sometimes, lot level data they would, but they would not send us any serial number data.
Yeah, and so it requires the company to actually asks for that information. So if it's your 3PL who's actually helping you process the return, you need to work with them to actually ask for that data, right? And again, fully acknowledging the fact that sometimes the patient or the clinic will say, hey, I threw away the box already or whatever. But I think these mechanisms are in place so that you're trying to reduce that amount of loss kind of profit in this particular case, right? Because if you can catch one of these things, that profit that you're not returning to the customer goes directly to the bottom line of either the wholesaler or the manufacturer. So every single one of these actually do count.
We actually have a returns team
Okay.
who works out of India. We have a huge returns team there, and we have a scenarios where we got a batch. I mean, we do a one-time buy sales, right? We got a batch from one-time buy, which is, I mean, technically it should not be. It is not liable for any return
Okay.
or any credit, I would say. But they send that back and they got the return. And then we found it like 3 months after later.
Yeah, no, certainly. I think there's one of the other things that I run into a lot is product diversion type things, and every day you just learn about different ways companies or people try to cheat manufacturers out of the system. So it's a problem for our industry, and so whatever we can do to try to catch these things, it's just better business for the manufacturers and the wholesalers. So. But no, I agree with you. Nothing is going to catch all of these things, but baby steps, and because all of these baby steps do go directly to the bottom line of the company.
So I want to know more onto input, right? So when you says there is a significant saving for MOT, so what are the input point for determination?
So the inputs to make that determination, historically in this situation, they looked at spot rates from airline providers, and then routing guide ocean rates. That's basically it, which is how the decision was made. As we switched on to the new model, the way that we did was we took historical information from ocean carriers, and we got again historical air rates and historical new spot rates from ocean carriers, from air providers, forgive me. So both of them, we had that as available. Historical information was never looked at from a cost standpoint. Then we added multiple factors onto it, which is what was the service. So for example, if you ship something CMA, right, Hapag, their published schedule transit time was, let's say, 21 days. What was it actually? And what is the difference in terms of the port of load and port of discharge, right, end to end? Are they transloading? Right? In some cases, they transloaded at Busan. So if you transloaded, what happens? So we looked into the transit time reliability. Then we also looked into how many nodes are they touching, meaning you're sending it off to the ocean provider, they're transloading it, you're unloaded, then you dray it to some other location. From drayage is when you finally ship it to your final destination. Or in some instances, it comes in via Seattle or Tacoma or Los Angeles. And then they are railing it, which they didn't know, but the ocean carrier is responsible for it, that they were railing it to Chicago, and from Chicago they were distributing it. It's just that we opened up that a bit more to understand what are the different nodes, what are the different touch points, and we started to minimize the touch points because we started looking at historical information. So one, cost, two, service, right? Then we looked at inventory information, which is the third input. What is the inventory was never considered in expedites. What is the inventory? At what location? What is the SKU? Do you have inventory at local sites? What's the accuracy of the inventory? Then you make the expedite decision. You try and expedite it from like a warehouse in Ireland to a warehouse in Chicago. You don't expedite from Ireland if you can move it within a local warehouse. Again, because it was never considered, right? Do you need that inventory at the other location? Do you have supply? Do you have enough safety stock? So inventory became a big part of that calculation before you decided. So those were the three main inputs as we decided the new mode of transportation.
I think if I were to add, I think the inventory add is probably the biggest increase in terms of the accuracy of this particular decision, because now we know if we will expedite when there's a low inventory situation. It's basically as simple as that. And if you don't take those inventory into account, then you're just not having that visibility, and so you're making these types of decisions a little bit more blind.
Sorry, one more follow-up question. So all these, I think I'm just gonna stand up. So all these data point that you mentioned is built in. What you explained just now is built into the software, or
the information was in silos essentially. One was sitting in the transit time information wasn't anywhere. It was just in spreadsheets. Inventory information was sitting in a different system. The order information was sitting in their ERP, right? Some of the orders, etc., was sitting in their TMS. So we had to essentially bring them all together, right? And that was one of the biggest challenges, which is their TMS system didn't talk to ERP, and that didn't talk to their planning system. So they had no visibility into inventory as they were making the decisions.
Okay, we are at time. Thank you guys very much for your presentation. It was a wonderful presentation.